Introduction. J.J. We shall also study some fundamental information about the atomic nuclei. Thomson's model of atom.
Model of atom. After the discovery of electron and proton, it is vital to know how these particles are arranged within an atom. J.J. Thomson told that the atom consists of a uniform sphere of positive charge and the electrons are embedded in the sphere. In this model, the atom is visualized as a putting of positive charges with resins, that is electrons, embedded into it.
According to Thomson's model, every atom consists of a positively charged sphere of radius of the order of 10 to the power minus 10 m, in which entire mass and positive charge of the atom are uniformly distributed. Rutherford's alpha ray scattering experiment. Discovery of atomic nucleus.
Rutherford model. Rutherford argued that because of moving electrons would be accelerated towards the center of the atom, it must radiate energy. The radius of the orbiting electron will thus become smaller and smaller until it dropped into the nucleus. Scattering experiment. Rutherford found that when alpha particles were passed through a thin sheet of metal, majority of them continued their straight paths. Some were scattered through large angles, while very few were even thrown back as if they had collided with something solid impenetrable in their straight path.
It is an important experiment which led Rutherford to discover of atomic nucleus. Impact parameter. Impact parameter is defined as the perpendicular distance of the initial velocity vector of the alpha particle from the central line of the nucleus when the particle is far away from nucleus of the atom. Spectral series. The spacing between lines within certain sets of the hydrogen spectrum decreases in a regular way. Each of these sets is called a spectral series. Limitations of Rutherford atom model. In Rutherford atom model, an electron is revolving around the nucleus and is constantly experiencing a centripetal force. Therefore, the electron has an accelerated motion. According to classical electromagnetic theory, the electron must radiate energy in the form of electromagnetic waves. As the revolving electron loses energy continuously, it must spiral inwards and eventually fail into the nucleus. Bohr, model of hydrogen atom. Bohr's explanation of spectral series of hydrogen atom. Bohr offered the theoretical explanation of the spectral series. They are Lyman series. The Lyman series is obtained when an electron jumps to the first orbit, that is n1 is equal to 1, from any outer orbit, n2 is equal to 2, 3, 4 and so on. Balmer series. The Balmer series is obtained when an electron jumps to the second orbit, n1 is equal to 2, from any outer orbit, N2 is equal to 3, 4, 5 and so on. Packen series. The Packen series is obtained when an electron jumps to the third orbit, N1 is equal to 3, from any outer orbit, N2 is equal to 4, 5, 6 and so on. Bracket series. The bracket series is obtained when an electron jumps to the fourth orbit, N1 is equal to 4, from any outer orbit, N2 is equal to 5, 6, 7 and so on. Fund series. The Fund series is obtained when an electron jumps to the fifth orbit, N1 is equal to 5, from any outer orbit, N2 is equal to 6, 7, 8 and so on. Every atom consists of a central core called nucleus, in which entire positive charge and almost entire mass of the atom are concentrated. A suitable number of electrons having as much negative charge as the positive charge on the nucleus revolve around the nucleus in circular orbits. The centripetal force required for revolution is provided by the electrostatic force of attraction between the electron and the nucleus. Bohr's second postulate defines these stable orbits. According to Bohr, electron can revolve only in certain discrete, non-radiating orbits called stationary orbits. For which total angular momentum of the revolving electron is an integral multiple of h by 2 pi, where h is Planck's constant. Thus, the angular momentum of the orbiting electron is quantized. The emission or absorption of energy occurs only when an electron jumps from one of its specified non-radiating orbit to another. The difference in the total energy of electron in the two permitted orbit is absorbed when the electron jumps from inner to the outer orbit, and emitted when electron jumps from outer to the inner orbit. Energy level diagram. Energy level diagram. A diagram which represents the total energies of electron in different stationary orbits of an atom is called energy level diagram of that atom. In this diagram, total energies of electron in various stationary orbits are represented by parallel horizontal line drawn according to same suitable energy scale. In this animation, showing that the spectral series of the hydrogen atom, the principal quantum number is n, labels the stationary states in ascending order of the energy. The highest energy state corresponds to n is equal to infinity and has the energy E is equal to minus 13.6 by infinity square is equal to 0 electron volt. As n increases, energies of the excited states come closer and closer together as shown in the animation. In this energy diagram, we can calculate the energy frequency, wave number, etc. of any line of spectral series of hydrogen atom. A diagram which represents the total energies of electron in different stationary orbits of an atom is called the energy level diagram of that atom. In this diagram, total energies of electron in various stationary orbits are represented by parallel horizontal lines drawn according to some suitable energy scale. De Broglie's explanation of Bohr's second postulate of quantization. According to de Broglie, a stationary orbit is that which contains an integral number of de Broglie waves associated with the revolving electron. Angular momentum of electron in nth orbit must be an integral multiple of h by 2 pi, which is the quantum condition proposed by Bohr in second postulate. Excitation and ionization potentials. The minimum accelerating potential, which provides an electric energy sufficient to jump from the inner mass orbit, ground state, or one of the outer orbits, is called excitation potential or resonance potential. Thus, ionization is the phenomenon of removal of an electron from the outermost orbit of an atom. The minimum accelerating potential, which would provide an electron energy sufficient just to remove it from the atom, is called ionization potential.